I'll sleep when I'm dead. Hey guys, Mr. Shaw. I think I got one more in me tonight. Let's go ahead and get right to it. We're going to talk about the quadratic formula and something you've probably never heard before. Again, this is called the discriminant, and we'll talk about it in depth today. So again, you've learned the quadratic formula before. We're going to do a bunch of examples just to kind of get you guys back into the swing of things as far as that goes, and I'll introduce you to the discriminant as well. So a couple learning objectives, again, just what I said. Solve using the quadratic formula, and then we'll be able to use the discriminant at the end of this video. So let's get to it. Vocabulary, you guys know the quadratic formula, again, or you at least have been introduced to it. We will talk about it in the next slide. Again, you know that it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, and that's when you're talking about ax squared plus bx plus c equals 0. A can't equal 0, and then a, b, and c are all integers. And that's pretty much it. Now again, it's going to be applicable pretty much anytime. You can use it anytime, that's for sure. And then the discriminant is actually just this part you see right here. Okay, and it's not even the square root. It's actually just b squared minus 4ac. And we'll talk about that a little bit more in depth later. So let's go ahead and get into some quadratic formula examples. Now again, here it is, the quadratic formula in all its glory. Again, you can memorize it using the Pop Goes the Weasel song. It helps, I promise. Alright, so again, I'm not going to go over it again. We already talked about it. Let's do it. Now, the thing about the quadratic formula is that it is extremely useful when factoring doesn't work, and when you guys remember all those horrendous problems we were doing in the last video about with the completing the square and all that stuff. There's no reason for us to have to complete the square when we have an odd number in the middle here for b. Okay, there's no reason to do that. We can just use the quadratic formula. So again, I know that a in this case is 1, b is 5, c is 2. So let's plug it in. So it'll be x equals, again, b in this case is 5, so negative 5 plus or minus the square root, again, 5 squared minus 4 times a, which is 1, times c, which is 2, all over 2 times 1. So I'm going to just do some scratch work kind of for the discriminant work anyway. So I know 5 squared is 25. Negative 4 times 1 is negative 4, and then negative 4 times 2 is negative 8. So this is going to become the square root of 25 minus 8, which is the square root of 17, maybe? Yep, it looks right to me. So again, this whole thing is just going to simplify to the square root of 17. Again, we can't break down 17. There's nothing we can do with that, so we're just going to leave it. So this will be x equals negative 5 plus or minus the square root of 17 all over 2. Now usually I would want you guys to break that down, but again we can't. So let's go ahead and I want to pull out my calculator just to kind of get into a little bit more into it. So we can talk about that the square root of 17, let's find it. Let's see what we got here. So square root of 17, oh I'm sorry, I guess we got to do it backwards, my bad. 17 square root is 4.123. So this is going to be 4.123, and we can kind of go ahead and get some decimals for this. So it'll be x equals negative 5 plus 4.123 over 2, and x equals negative 5 minus 4.123 over 2. So let's do this one first. This will be a little bit easier. So x equals negative 9.123 over 2. And we can go ahead and simplify. Actually, let's do this one. We might as well just do them both at the same time. So this one will be negative 0.877 over 2. Doing some mental math this late is a bad idea. So we can now go ahead and get our calculators out again. Oops, sorry about that, guys. So let's see. So this one, again, in this case, is going to be, the first one anyway. So 0.877 divided by 2. Again, I know it's negative anyway. So this will be x equals And I didn't even look at it. What was it? 0.4385. So 0.4385. That'll be our first answer. And then this one, let's see again. Well, it'll be, again, so I know it's negative, so it's going to be 9.123 divided by 2. So 4.56, let's round up. So 4.562. And there you have it. These are our two roots of our quadratic equation. And again, remember guys, can't forget is that whenever you get x equals, when you're talking about quadratics, it's always going to be wherever the parabola hits the x-axis. All right, it's really important to remember that. All right, let's get in. Let's keep going. So second example, and again, I keep not including this guy. Let me move these real fast. There you go. All right. So again, we're going to use the quadratic formula. So let's define a, b, and c. So a equals 1. B is -6, and C is equal to 2. Now again, this one is a good example of one that we could use that we could complete the square on pretty easily. But again, we're practicing quadratic formula right now, so let's go ahead and do that. So it'll be x equals, again, -6 for the negative b, so it's going to be +6 plus or minus the square root of -6 squared minus 4 times a, which is 1, and then times c, which is 2, all over 2 times 1. Now again, I'm not writing the formula out. You guys should have that on your paper. Okay, again, make sure you're just following along with me, and we'll keep going that way. So let me do my scratch work for the discriminant. So -6 squared is 36. -4 times 1 is -4. -4 times 2 is -8. So this will break down, again, this is going to become the square root of 28. And we can actually break that down. Let's go ahead and do that. So this will become the square root of 4 and the square root of 7. And the square root of 4 is 2. So 2 square root of 7 is what this whole thing breaks down to. So 2 square root of 7, just like that. And now we can go ahead and rewrite it. So 6 plus or minus 2 square root of 7 all over 2 times 1 is 2. Now one more thing I want to point out before we go any further is that you see that each one of the coefficients, each one of the real numbers anyway, is divisible by 2. So I'm going to go ahead and divide by 2. So again, if I do 6 divided by 2, I get 3 plus or minus, and 2 divided by 2 is just 1, so I can just write the square root of 7. And this will be, or these will be my two answers rather. All right, let's do one more for the quadratic formula, then we'll move on to the discriminant. Let's look at this guy. So again, you'll see here that it's not equal to 0, so we need to go ahead and make it equal to 0. Again, you see I skipped a couple examples, so pay no attention to that. But again, in this case, I'm gonna go ahead and subtract this 6x over, because again, it's hard to tell what my a, b, and c are without it equal to 0. So it's going to be 2x squared minus 6x plus 13 equals 0. So I know that a is 2, b is -6 again, and then c is 13. So let's plug it in and see what we get. So it'll be x equals -6, so +6, plus or minus the square root of -6 squared minus 4 times a, which is 2, times b, which is 13. All over 2 times 2. So let's go ahead and do our scratch work. So again, -6 squared is going to be positive 36. Let's see, 2, again, it really doesn't matter what order we do this in, so it would be -4 times 2 is 8, and then 13 times -8 will be -104. So minus 104. All right, and then again, I'm using my calculator just to make sure. I don't want to throw you guys off here. So 36 minus 104 is going to equal -68. So this is going to be all equal to the square root of -68. Now, usually that would have thrown us off, but we now know about complex numbers and imaginary numbers, so we can go ahead and use these. So again, factors of 68. I've got 1 and 68, 2 and 34, 3 doesn't work. 4 should work. I think it's 4 and 17. I think we've done this one before, actually. So yeah, it should be 4 and 17. And I know that that's going to break down. That's the lowest it can go as far as perfect squares go. So 4 and 17 is what I'm going to use. But again, I'm going to have to make it I on the outside. So this is going to be square root of 4, square root of 17. Square root of 4 is 2. So this will be equal to 2i times the square root of 17. So all this will break down into 2i times the square root of 17. So let me rewrite it. So it'll be x equals 6 plus or minus 2i times the square root of 17 over 2 times 2, which is 4. Now again, you see that each one of my terms is divisible by 2, so I'm just going to kind of divide everything by 2 just to kind of simplify it all. So this will be 3 plus or minus, again 2 divided by 2 is 1, so just I times the square root of 17 all over 4. Now you notice I haven't been doing decimals. Again, with the there's no way to do decimals with the imaginary numbers. Alright, so don't worry about that. Again, pay close attention to what the directions are asking you, though. If they're asking you for decimals, make sure you give them decimals. If they're asking you for just, you know, the whatever roots they want, that's fine too. You don't have to do the decimals. Alright, so let's talk about the discriminant. Again, the discriminant is just going to be b squared minus 4ac, and again, it tells us how many and what kinds of roots the equation has. Again, if I had done more examples, you would have seen a lot more of this, but I'm going to go ahead and go through them anyway. So the first thing you'll notice is that if the discriminant is greater than 0 and it's a perfect square, that means you're going to have 2 real rational roots. Now again, it's not necessarily going to be even numbers, or like excuse me, I mean integers is what I mean. Okay, it's not always going to be integers, but again, whenever rational means fraction, so whichever way is going to work there. But again, you guys need to still be familiar with those terms. The next set is going to be when the discriminant is greater than 0 but not a perfect square. You'll have 2 real but irrational roots, meaning that there's going to be a square root in the answer. Okay, this means that there's a square root in the answer. Okay, and then this one is no square root in the answer. Maybe that's a little bit, hopefully that's a little bit clearer. Okay, next one is that if b squared minus 4ac equals 0, then there's going to be 1 rational root, and that's when the square root cancels. Again, you'll see that anyway. And then the next one, I think that's the last one. Yep, okay. So the last one is when the discriminant is less than 0, that means there's going to be 2 complex roots, and that is going to involve I. And again, that was just like the last example we did. I'll write down example 5 just so you have an idea of what to expect with that. So in this case, we're going to do, next couple, we're just going to find the discriminant and then tell what kind of answers we're going to have. So in this case, let me get this equal to 0, so add 5 over. So x squared plus 3x plus 5 equals 0. And we know the discriminant is b squared minus 4ac. So in this case, it's going to be 3 squared minus 4 times a, which is 1, times c, which is 5. So 3 squared is going to be 9 minus 20, so negative 11. So that means that if you go back to our chart, okay, it means that we're going to have 2 complex roots whenever the discriminant is less than 0. All right, so we're going to have 2 complex roots. All right, let's keep going. You see here again, I'm going to subtract this 11x over. Whoops. So this will be x squared minus 11x plus 10 equals 0. So again, b squared minus 4ac. So plug it in. Again, we're going to have negative 11 squared minus 4 times a, which is 1, times c, which is 10. So negative 11 squared is 121 minus 40. So this will be 81. So now I know that 81 is a perfect square. That means that we're going to have 2 real rational roots. So 2 real rational roots. And that's it for me, guys. I'll see you in the next one. Take it easy.